Very welcome to this joint webinar on waste heat utilization, digitalization, and crowdfunding. We'll present innovative technologies and discuss these three themes around three projects, which are Reheat East, Grid CE, and Grid Geo. These are Interact Danube and Horizon I3 projects, mostly around capacity building and in line with the green energy transition, aiming to reduce waste in energy use and increase the capacity of regions, municipalities, and SMEs in developing value chains around green energy. And Grid Geo is specifically focusing on geothermal, while Reheat East is focusing on district heating waste heat. So this webinar enters into a series we have already organized last year around crowdfunding, peer-to-peer finance, innovative financing, and also waste heat utilization. And today we have with us Alessandro Murazzu from IdroGeo on behalf of the Grid Geo project. Alessandro is representing IdroGeo, which has a very innovative solution using heat pumps in Montecatini Terme, or in the historic city center of Florence. He will talk to us about this low enthalpy geothermal utilization. We will have Benoit Collas from Enerfip, which is the leading European crowdfunding service provider. He will tell more about Enerfip. I won't read this out. And we will have Parkish about from Sewergy, and he will present us a very innovative solution on waste heat utilization using large-scale heat pumps to use energy in cities, large-scale heat pumps for demand response, and very innovative digital solutions in cities that has been tested and used throughout several cities in Central and Eastern Europe. So I give the floor, I stop here now, I give the floor to Alessandro, and I let him come in with his presentation, sharing his presentation. Each speaker will speak about their solutions in about 15 minutes, and then we will have about a 15-20 minutes discussion throughout the chat. If you have any questions in the meantime, feel free to put it in the chat. We will read it out loud. I will also share the contact details of speakers, so you will be able to contact them directly, and we will have all the recordings and the presentations available online. So, Alessandro, you have the floor.
Okay. Thank you. Thank you for the presentation and for the invitation. And I'm Alessandro Murazzu, a geologist, and I will present to you some projects that try to involve and to increase the efficiency capacity and the renewable energy that can be used in some towns for climate and for using for cooling and for heating, and also for district heating in some particular area, and especially where we have the resource, the water resource. And so in the same case, we can study a system with low enthalpy energy and with fresh water, and also with medium enthalpy and high temperature water from the ground, the water level. So as the title say, the low energy geothermal project and for heating. and cooling system and power generation, especially where we can see in the second slides. Wait a moment. Okay, we have three systems that we present to you, and especially in the historic center of Florence is one UNESCO area, and one for district heating in Montecatini. And then we have another very interesting project where we are now working also this week. And this is a new system always for climate, very big building in near Milano, and in the north part of Italy, near Varese. So the first three that we see is Opera del Duomo, is the main church in Florence. This is the Dome of Florence. That have one museum in the center of Florence, near the Dome, and another is another museum always in Florence, in the center of Florence, near to the church of Santa Croce. The other is one industrial area near the airport of Malpensa, Milano. And in the end, we see also the district heating system and the projects in Montecatini Terme. It's a thermal area in Tuscany, always in Montecatini, that is between Florence and the sea in Tuscany. And we use this hot water for a project of district heating system. So starting from the first, you see our system and our building. The building is Palazzo Compagni, and the area is the red circle. It's a very complicated area for drilling because we are in the middle, in the center, in the middle of small road and no traffic area, and also very historical monument and historical building there. So the aim is that you see on the left there is the river, the Arno River, that is the river that bore Florence, and also that give to Florence a lot of problem of flooding, as you know. The last one is when I born in 1966, and was destroyed mostly of the parts of the library, and a lot of problems for flooding. But in the same time, the river has a good gravel sediments, alluvial fund above the underground of Florence, and there we have a good efficiency water table that can be used for heating. And so now at the moment we are involved in a lot of projects over there. And now today I will show to you the most important, the two most important. It is the building of Dome that you see near. This is our Palazzo Compagni, and after that I will show you also the other project, always in the center of Florence, that is the other church, Santa Croce, is very important. So you see the distance from the river is 700 meters. And our project is aimed to drill some wells in where we can drill, so where we can enter with a rig, with a small rig, because the wells, the deep of the wells is around 20 meters, and we build the project for 2 wells of extraction and 2 wells of injection. The geology is, you see on the right, the table and the map. You see that the geology is composed by the alluvial sediments, mostly. First of all, we find some gravel, and then below we find the rocks that outcrop in the hills nearby the center of Florence. The water table is especially located in the sandy and gravel sediments, alluvial sediments due to the alluvial faults of the Arno River. The piezometric are between 41 to 42 meter sea level, and from the ground is 7-8 meters from the ground level. On the right, you see the stratigraphy, and below the first layer, that is one anthropic sediment. We find the gravel, and we find the sandy and gravel, and below we find this aquifer that is located, you see on the right, in the blue circle here, and we see that the groundwater level was around 7.5 meters from the ground level. This is very important to know, of course, due to the position of the heat of the pump, of the ESP pump to pump the water for the geothermal system. And it's important also because we need some some free area to inject the water without problem with the building. So it's important to study that, of course, when you reinject the water, you have one rise up of the groundwater level, and this rise up cannot be one problem, or cannot damage the foundation of the building. So according to this, we build a model, hydrogeological model, that's where we increase for the injection and extraction flow rates, that is about 8 liters per second, and the maximum thermal gradient for the reintroduction, the Italian law say that has to be not more or less of 5 degrees. So we have 4 plus 5 degrees during the summer, and minus 5 degrees in the winter at the maximum. According to this condition, where you see the water table level here, and according to the flow that's arrived from this direction, we build the position of the extraction well, and also the position of the reinjection well, to go out the water again towards the Arno River. We started from a general regional study, and then we realized our model. And now I can explain to you this model. As you see, our model touch all in the summer, and a little bit less in the winter. Also the dome, but when we arrive at a distance of 180 meters, we see that the effect of this reinjection is zero. And but the law asks to us, the regulatory system asks to us to model this system to have no change more than 1 degree in the area nearby our system. So we can build this system, but we cannot change the hydrogeological condition around the area. So according to this model, we can realize this system without an increase of temperature that is at one distance of more than around 20, 30 meters in the end of the story. And this is due to the good efficiency and good discharge of our water level and hydrogeological condition in the area of Florence. So as I explained to you, there is one the hydrogeological simulation consider one temperature at maximum 23 degrees during the summer and of 11 temperature degree in the winter. So our hydrogeological and geothermal model say that the variation is compatible with the construction and with the other hydrogeological system. So you see, I resume here that is 2 extraction wells and 2 injection wells. And the discharge is 8 liters per second for well, and at the maximum the discharge is 1.5 liters per second. This is also the total amount is around 500 cubic meter per year. So here we show this the projects. Now I show this, then I go quickly with the other projects. But you see the diameter of the drilling is 600 millimeters, and the piping and the casing is 225. So the capacity, the nominal cooling capacity is around 254 kilowatt each, and so we arrive at 762 kilowatt in total. And the electrical the COP performance is calculated for 4.2, and electrical absorbed by the pump is 61 kilowatt per pump, for 2 pumps. The other system, I go quickly now, is similar, very similar. We are in a different position, but we are in the same condition because we are in the center of Florence. Where we have the river is nearest than in the dome, and the system, mostly the same power, hydrogeological power condition and production. We are in a very historical area where nearby the church, and this building is the building that we want to climb at. So as the other, I don't want to be again what is the situation, but we have the same hydrogeological condition. And also we see the stratigraphy of the system. Here you see always the groundwater level table represented in the model, and also here always they are the same condition of temperature. And in this condition we have also here the model, and you see this model that where we model the hydrogeological variation is around 75 meters for 150 and for 115 meters during the summer, and same mostly during the winter. So the temperatures are mostly the same that I show for the dome, And also here we find the compatible variation from the project. Here you see also in this case we have one larger borehole drilling diameter, but the casing is in PVC. Pipe diameter is 225. One important thing is that usually we try to realize one larger pipe for the injection wells, and also the filters is more for the injection well, because usually the problem that we have is that you can extract more water, but it's more difficult to reinject the water in the same aquifer. And so we want to stay more large with more filters area, and so to increase the injection, it's important to have different conditions from extracting and rejection. More permeability in the rejection, of course. And here there is another project, but there is also another condition that's important. That we have in Milan, we have in the industrial area, we build 6 wells, 3 of injection and 3 of extraction. But here the aquifer is more productive than in Florence. That's a very important thing. So the productivity of the aquifer is one of the most important things, of course, to using the geothermal low enthalpy system. And so we are now with discharge of around 40 liters per second. It is the most important thing. So medium, we have 22 liters per second, but in this condition, the discharge can be more also to 40 liters per second. So you see, and at the end of the story, that we can save 50% of the cost to climate this building in the same condition of historical area or of the industrial area. And that's important to use the water to inject the same quantity of water. We can do it, and it can save a lot of economics and pollution condition. And in the end, I want to show you a particular condition that is one district heating project in Montecatini. That is one rock area where we have a lot of cross section with thermal water, and that now we are using only for thermal use. And in our project, we use with heat pump, also with 600 kilowatt for each pumps. We use this water to inject at one distance of 1,000 meters around, far from the thermal area for a district heating. It's like similar that we use in Paris. You know, in Paris there are a lot of these projects. We arrive at the deep less than 1,000 meters, around 1,000 meters, instead of Paris, where the system are located at deeper wells with more than 2,000 meters. Here we find water of around 50 degrees at the deep of 1,000 meters. And so our aim is to use this water with heat pump to generate climate and for a district heating of the thermal town of Montecatini Terme. Thank you. Sorry for the 5 minutes of delay, but I tried to give you all the information. If you have some question, you can ask me what you want. Thank you.
Thank you, Alessandro. It was very interesting and very in-depth, highly technical presentation. Thank you really very much. While Benoit is preparing to share his presentation, I just wanted to call your attention, Alessandro, to the question in the chat. There was a question addressed to you on the economics, and I see you had a slide on this. And for the information of participants, we will share all the slides, but I just read you out loud so that you can prepare for the discussion. So what are the first steps when a municipality is thinking of realizing such a solution? What are the first steps to identify technically and financially feasible shallow geothermal opportunities in a municipality for a given building or groups of buildings, and how long does it take, and how much funds are needed for such a pre-feasibility analysis? And this is somehow linking us to the financing now, to Benoit's presentation on crowdfunding, because this can generate really a good wide popular-based funding. So Alessandro, we are prepared for the discussion, and Benoit, the floor is yours. Thank you.
Better with the micro, sorry. Thanks, Kristina. Thanks, Alessandro. Can you hear me properly? Can you see the screen also? So
Yes.
Everything is on good tracks. So my name is Ben. I work at Enerfip. Enerfip is a French-based company, and we're active in the financing of everything related to energy transition. In two words, our model is, let's try to be simple. We connect retail investors and project owners who have huge projects to develop, as we could just see with Alessandro before, for example. Our main kind of project is linked with energy transition, as I said, and mostly it will be with solar projects. Okay. So let's start. We are a 10 years company, so let's say that our pillars are easy. It's a reduce the footprint of our investments and generate some good returns for you. This is our story. I saw in the presentation sent by Kristina before that we started 10 years ago, and last year, let's say the last November, December, were super intense for us because initially we were in France. We developed internally some other countries, Spain and Italy. And end of 2025, we acquired two companies, one competitor in France called Lumo, and one other in Amsterdam called geothermal. Here are our key figures. So we always account for the project that we finance. So the 500 that you can see on the screen. And the amount that we raise for the project owners, so the 800 million euros. We have a community of 60,000 retail investors, and we are a team of more than 60, mainly in France, but also in the other geography I mentioned before. So we're active with this crowdfunding license, a kind of investors to project direct investment. But also we created 2 years ago a fund activity. So let's say that same, it will be retail investors, but in this case it will be more, you won't invest in a single project, but you will invest in a group of companies, project, and so on. Now I will present you what we can bring for developers. So what do I mean by energy transition? It will be mainly production. I said solar, for example, but also efficiency. We did some like uh, renovation of some buildings, but also mobility with some like construction of charger for e-vehicles. We can work from the early stage when it's development phase, or the construction phase, or much less risky the operation phase when everything is in order, the project is clean, and we already have some feedbacks from the market. So we can do several kind of financing, everything related to innovation. When we try a new model, for example, 1 year ago, we finance some like wind turbines, but you know the axe was totally different than the classic axe that we are used to see. We can do some acceptability. We call it when a developer would like to go in a particular area and is trying to convince and to only propose an investment for a small community. So let's say, for example, in France, it could be a village, it could be a department, and so on. We can do some portfolio in order to reduce the risk of the investment. It's better to take several projects together. So I will ask the project owner not to finance a single like project in I don't know in which area in France, but several projects. So that way we will reduce the risk. So let's say that we can take some different maturities, some different technologies or so. So this risk will be split, and we will have more chance, even if it's still a development phase. We can work with bridge financing, and so your project is almost ready, but classic banks are long to come. So sometimes at Enerfip we're much more faster to propose audit and financing. So it's good for the client, and some corporate finance, but this is a little bit bigger. So far, as I said, most of our projects have been done with PV and wind, but also some hydro, bioenergy, and energy efficiency. We try to finance more infrastructure because for retail people, it's much more easy to say, oh, I invest in this project. It's located in this address. I know that it's generated that sum of megawatt per hour and so on. And mostly we work with bonds. One of the main indicator is also the default rates. The default rate is the comparison between the default, it means the amount not paid, to the total amount that we raised, the 800 million I mentioned before. So the default rate is less than 1%. So for us, we're very proud of it. Then I try to pick up, you can see on the screen, I try to pick up 3 different projects for today's. One on the left called Green On. After you can follow with the link if you want. The first one is in Hungary. It's a Green On. It was a corporate one for project in development. This is the kind of situation when the developer has several projects for this one. So this, for us, it was the idea to reduce the risk that way. So you can see that more than 1,000 people invested, the 1,427. And the total amount was 1 million euro that we raised for this company. The second one called Saverne, Service Énergétique, sorry, it's in French. Saverne is its network in a like city in East France. So it was a huge wood factory used to send heat in all the city. It was for us much lower project with 30 investors and more than 200k euro invested. And then the last project is in Poland. It's called ID Energy. The sponsor, the client was Spanish, but the funds were going for this facility in Poland. Here it was a more bioenergy using rest of agricultural stuff to produce biogas. So how do we work? We have three phases. The first one is the preparation. We are like a classic boring bank. We will ask thousands of questions to assess that sponsor is fine and project is fine, including reviewing the business plan and so on, but also technical review. If everything is fine, let's move to the next one. We choose a contract and we put your project online. Project is online and investor will come and do their own market. I like this one, so I will invest. I don't know what I can. Today it's 100 euro. Tomorrow maybe it will be 100k euros. I hope so. And at the end, if we were aiming to get 1 million, so after a certain period, generally we put online 1 month online, and it's solved. And then you arrive. We give you the funds, and then we go to the repayment period. So we worked at the beginning mainly with French actors, but also more like diverse partners. And now what we can bring for the investors, I'm personally also an investor before I work at Enerfip. So the classic duration for the investment is between 1 to 5 years. The yield is between 5 to 9%. So from time to time, when we see an opportunity, but a big risk, we can go a little bit more than 9, but it's it's not frequent. You can invest from 10 euros and we don't charge anything for investors. We have a huge team of investor relations, so we can work in English, French, Dutch, Italian, and a little bit more. Because we are active in the energy transition, we also wanted to show the impact that you have on your money, of course, but also the impact that you have on Earth. So that's why we also propose a calculation of everything sold thanks to your investment in terms of production and the link with CO2 that you can discount thanks to your investment. Bonds are quite tricky because it's like fixed term, but we created a second market. So let's say that if you need cash and you want to sell your investment, you have the possibility to sell it in the second market that we created. Here we are. Kristina, I'm sorry, I have no idea of when I was supposed to terminate. I hope it was clear, and I will give you back the floor.
No worries. Yes, it was perfect. Thank you very much, Ben. You also received a question through the chat. So think about that until Pal is coming. I'm just reading it out. As you work mostly with the bonds, do you perhaps see it feasible these to be available on online investment platforms like Lightyear in some time? Background, well, okay, you read it out, okay? So it's a very technical question, I assume, by Tamás. So if you want to respond, but first I give the floor to Pal. Okay, if you are.
Thank you. I share my screen with you.
Thank you.
Can you see my screen?
Yes, very well.
So I'm on next screen. It's also moving the screen. Okay.
Yes. Yes.
Okay.
Go ahead.
So yeah, thank you for the feedback. So my presentation is a bit linked to presentation of Benoit and also Alessandro, because once we are talking about CO2 emission, of course we need to talk about the heating, because heating is responsible for most of the CO2 emission, and we are in the way of electrification. And once we are talking about electrification, of course, there are heat pumps having the most efficient solutions, like you have seen with Alessandro, heat source from geothermal heat sources. But those are water-to-water heat pumps, and they need heat sources. As I mentioned, can be geothermal, but also sewage is there, wastewater is there, and it's available. But the question is very exactly, and how many kilowatt we can extract from such a heat source. But before coming into the response for this, I can see that there are many solutions to use this energy. Especially with thermal, for example, in the middle, I have 15 years experience extracting heat for large projects above 1 megawatt with this technology. And also there are other solutions recovering heat from wastewater, ROE between 8 and 10 years. There are many projects available, and recently more and more for district heating companies. But the Sewergy solution is why special, because we come from the industry, from real experience, and we have experience on the real market, and we found a real fast solution to solve the problem of mapping this energy source. So the aim is to know where we can find this energy and how much is the potential. Just to give you an idea, here in Budapest, the potential is in between 200 and 400 megawatts. So a lot of energy can recover. To understand better, roughly 1 megawatt serve for 10,000 square meter building, or above 1 megawatt we can serve district heating supply as well. So it's quite a real solution for large scale, large building, and also in smaller solution. But for decision makers, we have to make it show where you can find this heat source. An important part is how much CO2 emission reduction we can achieve. As for example, Benoit said that it's a very important indicator for investors. And for this, we make a calculation using AI compared to gas boilers, how many we can save with electrified heat pumps. How does this work? How we can have this solution on the table? So as a first step, we have population data collection, and then we use the existing network of the cities. After we calibrate the data with real data, because companies, sewer companies, measure flow data at the end. They measure data at the sewage treatment plants and pumping stations. And we recalculated the map, and we have a nearly exact map of heat in a city. So as a first step, as I mentioned, there is AI population data collection, which is very interesting, that how much AI knows about us. So for example, in Budapest, we have 200 different zones of different population, which is detected by AI. It means we can see how many people live in a smaller area than district in Budapest. On the left side, you can have some data, and then we can put it on the map. And once we put it on the map, and we use also the map of the sewer lines, we can see how many flow is getting into the sewer lines using, for example, in Budapest, 110 liter per person produced by people in their daily life. And we assist with the production of industry, also the data that we add, and then as a next step we calibrate this. And as a final product of this procedure, we will have a map. And I wanted to show you this procedure in a very short 30-second video. Just let me show this and launch here. So as a first step, you see that on the map we can see the existing pipelines, and the AI collected the data with the population, and then the calculation is coming, and the software calculated the data with the calibrated data also that we put in. And as a result, we have this map. It means that any part of the city, we can say how many kilowatt or megawatt available. For example, it's one exact example from Budapest. In this road, you can have 7.7 megawatt, which means that more than 70,000 square meter building can be served from this place, and over 156 tons of CO2 emission reduction can be achieved with this project. And of course, the sewage flow is also detected and calculated. Of course, it's a useful tool, but who can use it? We see that municipalities, they do their master plans, they do their smart city plans, but also they have an obligation coming from the EU directive in 23, saying that all the city above 45,000 inhabitants, they are required to do their renewable heat mapping. And one of the heat mapping is sewage heat mapping, that it's feasible with this way, with this solution. Also, water utilities, sewage water utilities can make money out of it, saying that this energy source is not used, but they can charge also the use of this use in or experience in an energy bill is just 1 or 2%, but it makes money for the water utilities as well. And also there are other beneficiaries, maybe district heating companies, who can have their heat source, as you have seen with Alessandro, like the geothermal heat source, but also sewage heat source is available. In terms of what we have projects in preparation in Poland, for example, in district heating, or in Budapest, there is a large project of 40 megawatt, or there are several large projects in this area, because district heating companies aim to be efficient district heating company using more and more renewable heat source. And as also important for investors and real estate developers, because their financing comes from banks, and they have to comply with ESG rules. It means they have to be sustainable and they have to be green in their projects. So once they have their land to invest, it's an added value once they have a big main collector of sewer line or a pumping station where they can take out a lot of wastewater as a heat source for them. So also it can serve for them. As references, Sewergy produced already heat maps. The largest produced is the Budapest heat map and delivered within 2 months. Also a smaller map in Germany within 2 weeks were produced, and in preparation or just finalization phase, we have Sofia in Bulgaria, which is also a 1.3 million city. So it's also a very interesting, but the question is always the cost and time for people who think about this. So once we take a very rough estimation of a 1 megawatt project, similar, for example, in geothermal energy, the investment cost is between 1 million and 2 million euro. But if you see it, look at the cost of Sewergy for a project like this is very, very little. So just a little part that you can see here, which is very, very little. If you look at the time schedule of such projects, you will see that in the preparation phase, you take a lot of time measuring and double checking the flow and making estimations. Instead, with Sewergy, it's much shorter time. So for the total period of the projects, you save a lot of months instead of doing a long preparatory. And if we take on city level, you will see that cities have their traditional old method mapping. For example, Berlin had this making in 6 years Berlin Atlas, their heat map. It's very rare that cities they have their map like this, but Sewergy it's much faster to do this. So here you see the timeline, which is just let's say three months instead of let's say 36 months. And if we take the costs, we are in between 10,000 and 50,000 euro instead of 300,000 euro, 500,000 euro with measurements. You can see here that the difference is huge in between the using Sewergy solution and the traditional heat mapping. So we believe that this can be very useful for end users and make a big achievement for sewage heat use anywhere in Europe. So I try to be very fast with my presentation, leaving some time for the end. So I hope this was interesting for you. And I wanted to let the floor also for your questions. So thank you for your attention.
Very comprehensive and very clear, Pal. It was an excellent presentation. Thank you. And indeed, we take the time as needed for the questions. I was aiming for this 1 hour because at the end of the day everybody is busy. So I would give you back the floor according to the questions I listed out. In the meantime, participants, if you have any questions, please just raise your hand or write your questions in the chat. We'll also share the presentation. There was a question about this, and we will also share the recording of this webinar. We will share also your contact, so you will be able to contact the speakers afterwards. So coming back to the questions, yes, the first one was to Alessandro. I don't know if you have any insight into the well, at least about the first steps for municipalities aiming to explore these kind of solutions. So what are the first steps to identify technically and financially feasible shallow geothermal opportunities in a municipality for a given building or groups of buildings, and how long does it take? About how much funds needed for such a pre-feasibility analysis, and if you have any information about the return on investment or the cost savings, it's also very welcome. Thank you. Okay,
so it's I try to answer to this very interesting question, and so the first things that you need technically is to have the water, to have a good discharge of groundwater resource, so aquifer, a good aquifer. You can use also, if you have some drinkable water nearby, also thermal water, because you change only the physically the temperature, but you don't change the chemical, and you can work without changing chemical. So the first is to have the water. So the condition is different. If you don't have the water, you can use only closed loop for geothermal. And the feasibility study can, it means 1 month to realize this feasibility study. And the cost of one feasibility study can be around 10,000 euros to have a good feasibility study. But if you have no water under your feet, you can use only the closed loop, and the payback is around 12 years, 10 up to 10 to 12 years. Instead, in the same case that I present to you, where you have water, you can have some different condition. It's like a climate condition different from Hungary to Italy, or you can have some different condition for the deep of the aquifer, and so for the cost of the aquifer. And I can give you one example. For instance, in Florence, you have to drill until up to 20 meters, and the total cost of drilling is around 200,000 euros for wells. But in the same condition, you have more discharge, but in Milan, where you have to arrive to 100 meters, the cost can be double. So it depends on the cost of the drilling and the cost of the deep and the deep of the drilling, of course. So it's different. But usually I can be exactly that, say that in 1 month you can prepare one good feasibility study, and in one cost of 10,000 euros can help you to have a good feasibility study, pre-feasibility study analysis. And the payback of the water system, so open loop that I present to you using the water of the aquifer can be between 5 to 10 years, the payback of the investment. And the same time of feasibility study, of course. And so it depends. Usually the most important things to choose the feasibility and the method, the geothermal method, is the availability of groundwater in the ground. And you can establish also one limit. If you have more than 4 liters per second per well, can be a good choice to go to the open loop system. Of course, better if you have 40 liters per second, like in Milan. So the best condition are where we have more than 20, 25, 30 meters of gravel and a discharge certainly more than 4 liters per second, and certainly better if you have more discharge, of course. But the difference is the deep and the cost of drilling, because the heat pump is the same cost mostly between the water heat pump or air heat pump. So the difference is the COP, that is more efficient with the water, and the cost is only the drilling cost and the heat and the pump, the ESP pump, but can change this cost according to the deep of the wells. But usually we can stay between 5 to 10 years for the payback. And also the climate can help you, because if you have, like in Florence, need to use the heat pump in the summer and in the winter too, is better. It's better for the system and it's better for saving money. It's around can be efficiency. The efficiency of 50% can represent one medium that you can have, but the condition is to have the water. So I hope that I answer to this question. Anyway, I am available for other questions, or if you have more requests. Thank you.
Thank you, Alessandro. Tamas had another question to you, Ben, about the potentials for crowdfunding by the locals, potentially complementing the traditional funding for wastewater, waste heat utilization projects in France. Do you see any potential for this? This was similarly to some district heating and other projects already realized in that way. Do you think that would be a preconditions for this?
Yeah, listen, I'm everything really related to water, we are not expert with. 2 years ago, we tried to dig a little bit in this field of water. It was more not really link water and energy, but strictly water purification and so on. And I saw that it was a new a wall that we were not able to go because it's super complex and interesting. So this question is maybe a little bit specific. Let's say that for us, I said from time to time we do some innovation projects. So let's say that if that kind of project arises that is described in the chat, for us it won't be a classic project. It will be more classified as innovation. So it means that we'll have less facilities to study it. But if it's a nice project, of course, we will study and check if it does worth it to risk. And then I saw a second question related to taxation, which is always complicated. Let's say that so far we try to answer to this question of taxation, but taxation is already complex in each of us own country. And then as soon as we go abroad, it's again more complicated. So far we started to work on the taxation between the main countries where Enerfip is available. I mentioned at the beginning, and it's hard, but we're okay with it. Let's say that between France and Spain, we already finance more than 80 million euros, so it's good. But of course, the idea was to propose in Hungary a project of more than 5 years because you have much more tax incentive. To be honest, this one I understood, even if I don't understood much about taxation. I understood it because we have strictly the same shame in France. So that's why I can easily understand. But to propose it to French investor with French project is fine, but to propose it with external, like out of France residents, it's a long study. I don't know. It's it's again question of digging to get the information.
Thank you, Benoit. As you are an innovator in financing, I'm sure that this could be potentially a new way or a new direction for you.
Maybe in financing, but not yet in taxation.
Not yet in taxation, but financing new type of innovative projects. So maybe that's a new way to explore. Okay, Pal, you had also two questions. You had a very strong value proposition indeed. And what are the barriers when you're talking to stakeholders? What are the barriers to persuade them about this technology? This mapping. And the second thing is about the competition. Do you have any knowledge about similar solutions with references?
Yes, very good questions. So first of all, the main problem is the awareness, the knowledge about Sewergy, because it's a unique tool. There's no other like this in the world as far as we know. The closest is in New Zealand. This is quite far, and it's still with traditional methods. So this is the first thing. The second is the potential. The municipalities or companies, they don't know how much is. It's a very big potential. It's not used. And also for water utilities, it's a huge potential of income that is not used. So it's a bit the knowledge is missing in this field. This is maybe the main barrier here. And secondly, yes, there are companies. At least I can give you four. So that what I know well, of course. There are Huber, a German company. There are Energy, a French company. There are Shark, which is a Canadian company. So there are companies doing this. I'm saying only the large companies with large references, but there are other companies. So yes, the industry exists, and knowing Thermwatt, it's at least 15 years experience with implementing and operating such premises. So it's not as new as people may think, so their experience in this field.
Yes, indeed. Apology, it's not the competition, it's the rather complementary.
Yeah,
okay.
Was the companies, but it means there is competition on the market. It means that once the municipalities or real estate investors or district heating companies think to launch such projects, there are available technologies and there are available companies to make proposal for this.
Excellent. Thank you. I don't see many other questions coming in. So unless we have any other comments or final comments from you, I would thank you for your kind availability and attention to the participants who remained until the very end. Thank you very much indeed. We will have the recording online. We will send presentations and the contact of the speakers. And once again, thank you very much.
Thank you for your
Bye-bye.
attention.
Thanks,
Bye-bye.
Kristina.
Thank you. Bye-bye. Thank you.
Bye-bye.
Thank you.
Bye-bye.
Bye-bye. Thank you. Thank you. Bye-bye.
Bye.